Here we're asked to solve each equation, and remember that this one is without using a calculator. So when I am dealing with this problem here, what I can do is I can set each of the bases as the same thing. What I mean by that is if I look at the left side here, I start with, let's say, 2, right? In the right side, I have a base of 8. I'm going to use what I know about exponents to help me find a common base. So what I know is that 8 is really 2 to the power of 2. So I've just replaced that with 2 squared. Sorry, 2 to the power of 3. My fault. Is 2 cubed to the power of x minus 1. Now I know power of a power rule means that I multiply the two exponents here. So I have 2 to the power of x equals 2 to the power of 3x minus 3. Now, the nice part about when I have a common base is that I can just set the exponents equal to each other and solve. So from here, I have x equals 3x minus 3, where I'm going to say I got negative 2x equals negative 3, divide both sides, and get x is equal to 3 halves. So for the second one here, I have 4 and 8. So I know 4 is 2 squared. The hardest part here is finding the common base, in my opinion. I know 8 is 2 cubed. Now I multiply the exponents here to get negative 2x and 3x plus 6. I set the exponents equal to each other, and I solve. So negative 5x equals 6. X equals negative 6 over 5. And then lastly, I have 7 and 1. So this one's a little bit tough, but what we need to understand is that 1, remember, is anything to the power of 0. So if I know that fact, then this actually becomes pretty easy. I don't need to change the base over here because I know that 7 to the power of 0 equals 1. Now I have a common base. So I set my two exponents equal to each other, and I solve to find that x is equal to negative 3.